Okay, we're going to look at some inequalities today. And to begin with, excuse me. To begin with, I want to look at kind of just what the general solving procedure is for a inequality. So an inequality is just a expression. It can be linear, it can be quadratic, it can have all of the different classifications that we use in algebra. And the added thing, the new thing, what makes it an inequality is the fact that it has one of these symbols like less equal to, greater equal to, in it. Sometimes more than one. Now, the rules of the game are still the same here as they were when we were solving equations. The difference here is going to be what we have to do to denote our solution set, because unlike a single answer value for a conditional equation, we will get a range of values for our inequality. And there's two different ways to do this. We can use set builder notation and we can use interval notation. I'm going to try to walk you through interval notation. Set builder notation will mainly be for in class. Okay, so the rules of the game are basically the exact same as they were with equations. So if I want to work this from an intuitive place, say subtracting 2 from both sides, this is allowed. Whatever I do to one side of the inequality, I have to do to the other. Now, the kicker comes with this operation right here. When I multiply or divide, I have to be very, very careful about negatives, because when I multiply or divide by a negative, it's going to flip the direction of this inequality symbol. So in this case, we had a less equal to sign, and now we have a greater equal to sign. So in this case, I can see that the same techniques that I use to solve linear equations, they still work for linear inequalities. The added thing is when you multiply or divide by a negative number, we have to be careful about the direction of our inequality symbol. Okay. The last kind of new thing here comes from how we write our answer. And if you think about this like it's on a number line, then I found that 2 is sort of like my cutoff value for the solution set here. Now I'm supposed to have all the x's that are bigger than 2, and that means I can have anything over here on the right-hand side all the way up to positive infinity. It's a really bad infinity symbol. There we go. And I can also include 2 in my solution set because it says that it is possible for x to equal 2. So the way that we write this is very simple. I'm going to write it almost like an ordered pair. Let me move this up just a little bit. Where I write 2 comma infinity because I'm just reading from left to right on my number line. 2 is like the smallest number it can ever be, and then it goes on towards infinity all the way out to the right forever. Now the infinity symbol always has this parentheses around it because infinity is not actually a number, so we don't include it in our solution interval. And then the choice for this left-hand number is going to be dependent upon whether I have a less equal sign, a greater equal sign, or a strictly less or a strictly greater sign. So when I have a less equal or a greater equal, then I know that I have to include the 2 in this interval, and so I put this square bracket around it to denote that it is included. You can kind of think about this square bracket the same way that the colored in dot versus the open circle is for the number line. Okay. Now the other question I had is, how did I know that it goes from 2 to infinity? Notice that I'm just reading across the number line from left to right. So 2 is where it started and it went to infinity, so 2 was the first number I wrote down and infinity was the second number that I wrote down. If we went from the left-hand side until we get to 2, then I would have a negative infinity and then a 2 written that way. Some other examples. Excuse me, not why. Okay. Here I have a strictly less than. So notice that I can work this the same way that I'm used to working it from maybe linear equations. I will subtract 3. This gives me this expression. I will divide 2. This gives me this expression. Notice I did not multiply or divide by a negative, so I did not switch the direction of my inequality sign. So when I'm writing this in interval notation, I recall that on a number line, this would go from negative infinity to positive infinity, and my value that is kind of like my cutoff value is 3/2. Here I would have an open circle and then everything to the left of 3/2. Which means in interval notation, I will write negative infinity until I get to 3/2, and it does not include 3/2, and we never include positive or negative infinity. And so this is my interval notation for that. Sometimes we have 3-part inequalities. I've got a part on the left, a part in the middle, and a part on the right. Now, in class, I suggested that you should split these up into 2 separate inequalities just so that you do not get confused about the multiplications by negatives. If you mess that up, then it can mess your whole answer up. Now here we're going to get a set intersection as our answer, which means we're going to get 2 boundaries, one on the left and one on the right, that we have to consider. So I'm going to go ahead and solve this. Now notice in this case, I'm gonna do this kind of the way I suggested that you don't do it in class. And I just wanted you to see what it looks like so that you're at least familiar with it. So here I'm going to add 8. Now whatever I do to one side, I have to do to the other side, but there's 2 sides in this case. So if I do something to the middle, I have to do it both to the left-hand side and the right-hand side. Notice that that's going to give me 9 less equal to 6x less equal to 12. Now I can divide everything by 6. Divide everything by 6. I'll get 3/2 on the left less equal to x less equal to 2. Now, if we work this the way that we did maybe in class, what you would notice is that you get 2 different statements, that x is greater than 3/2 and then x is less than 2. What I wanted you to see about this is that this kind of expression is very easy to tell what our interval has to be, because all I have to do is delete this x and the inequality symbols out of the middle. When I write this in interval notation, I'll have 3/2 comma 2. And then since the left-hand side is inclusive, I need it to be inclusive of 3/2 because it can equal to 3/2. And since the right-hand side is inclusive, then I need the right-hand side to be inclusive as well. And we get this kind of statement. Okay, so that's kind of how interval notation works for inequalities. Just remember, the rules of the game are exactly the same. The only difference is when you multiply or divide by a negative number, you have to reverse the direction of the inequality symbols. And when you're writing your answers in interval notation, think about them as though they were on the number line from maybe Algebra 1, where it runs from negative infinity to positive infinity. If you want the region to the right of a certain amount, then you would write the number that the boundary is and then comma infinity. If you want the region to the left of a certain number, then you'd write negative infinity comma the boundary number. And that's how you know which direction it goes.